Dear Rustaceans, I have not forgotten about you. Even though I focused on object-oriented design for a while now, Rust is still my one true love. So let's sharpen those pincers and stretch those sideways walking legs and get ready for some more advanced Rust. Today I would like to convince you that the visitor pattern has an abundance of hidden beauty, even though it looks a bit off-putting on the outside, much like Rust in general. And of course, because it would be way too easy to just give you the finished code, you'll have to follow me on the way from what starts as a simple, nicely readable example to the trait-littered monstrosity of abstraction and indirection called the visitor pattern. Now seriously, I think you will see the advantages much clearer when we build this gradually. So, let's hop in. So to start off, I have a kind of minimal setup here that I require to show you the benefits of the visitor pattern. What we have here is two structs. One is a player and the other is a bow, which is kind of an item in a computer game, right? Both of those are structs. The player has position and health, and the item bow has a damage and a range. And what we'd like to do is we'd like to persist them, so save them to some kind of file. For this, we have an output directory, which will be the save files folder, and we have a function to create this directory here. And then both the player and the bow implement their own method to save themselves, or the information they store, to a file, and we'll do this to player.txt and bow.txt. The implementation is rather straightforward. So save to file takes a file name as a string and then opens a new file with the write option. We create it if it's not there. If it's already there, we truncated it and I will open it. And then we'll write a very simple unformatted line here with position and health. And much the same thing happens here for the bow. So you see some kind of duplicated code, already a code smell here. Except for that this bow, of course, has some different information to share. Because all of the operations that we do on files can, of course, fail, we'll just bubble up any errors that are std.io results, and we'll bubble it up to the main function, then the main function just forwards it to the user, so to say. If we were to run this, we would see that number one, it compiles and runs without any errors. And number two, we get those two save files for the bow and the player. Nothing special, and to be honest, those files are not of interest at all. We want to have a proper way of implementing this. So on first glance, everything looks fine. That's kind of clean code, except for the duplication, right? But it's definitely easy to read. It has some object-oriented design behind it, so seems okay, right? Well, besides the advantages that it is simple to read and write, and I will admit it was simple to write, we have a lot of disadvantages here when we look closer. Number one is that the way we designed this, or the way I designed this, violates the single responsibility principle. So the first principle found in the solid principles. The player should care about actions that modify its state. For example, like taking damage and moving. And of course, if you would be implementing this properly, you would have some of those methods here. I omitted them because it's not important for this example. But however, it should not be caring about saving itself to a file. And it's the same thing for the bow, right? Here in the items.rs file. Well, why should a bow or a player not know about how to store them? Well, because it's an entirely separate concern from what the bow actually does. The bow deals damage to the player, the bow has its damage and its range, and the bow can probably be picked up and stored into a container and maybe sold to a vendor. But saving it to a file has nothing to do with the bow item itself. We just need some data from it, but it's a separate concern. Also, the way this is implemented violates the open-closed principle, the second principle of the solid principles. If another method of saving comes along, for example, to a database, or via an HTTP post call, or to a JSON file, whatever, all those structs have to be changed. Now imagine, of course, we won't only have two game objects like the player and the bow. We'll have plenty of them, maybe hundreds. So if I want to change the way all those items are saved, I will have to change them in every single file. So it is not closed for change. Those are open for change, right? And we will have that change even though the behavior of the player or the bow itself didn't change at all. So that doesn't really make sense. Also, if we take a look at the item.rs and the player.rs, you can see that those two methods, save to file, are very, very similar. However, if we continue it like this, we will have save to file methods split throughout the whole projects, and this makes it hard to reuse common functionality. For example, like opening the file, which is exactly the same operation for both methods. Yes, this could be done with a utils module and free functions, but I think that doesn't properly convey the coherence here. And a, for now, rather minor issue, because we only have two game objects, player and bow. We have to call save to file for every struct, and this can get very tedious. We can't do this via loop right now. So let us now start to restructure things a bit so they make more sense. The first thing I want to do is I want to have a new file called persistence.rs in which we will have our persistence. For now, this is just a struct txt file saver, and it will save, or it will have as a member a save directory, which is a string. Of course, we'll have to define that this is a public module here, persistence, right. So now, what are the implementations for our txt file saver? At first, I'll have a new method. This will create a new txt file saver, and in here we can already have the create directory all for the save directory, so that we don't have to do this in the main function. And then we'll just create a new txt file saver with the save directory and return an OK here. Of course, we need some imports here, and now we're good. So the next thing is, if we want to open a file, that's going to be the same for every kind of object. So we have this in one common functionality. What we're doing here is we're taking a struct name. In the end, this will be something like player or bow. And we're concatenating the save directory we have here and the struct name at the .txt, because it's a txt file saver. What other file ending would you expect? And then we'll again open the file as we have it and return it in an OK wrapping. And of course, the last point here is we want to write to the file. This is also a method that is quite straightforward. We send in here the struct name that we have, which will be forwarded to our openFile method. And we have the content, which is a string. And in the end, we'll write all the contents as bytes, always bubbling up any errors, and return an OK. So far, so good. Those are the common functionalities that we will have in order to save anything to file. And now we just need two specific methods on how to save a player and how to save a bow. And I've got those ones in here. Let's just quickly import those two structs as well. Well, save player, of course, takes a immutable reference to a player. We don't need to change anything here. And all the save player does is it builds the content based on the position of the player and the health of the player, and then calls write to file with the struct name of player and the content. Very similar thing for bow here, except for that we're just building the content a bit different, but we're calling the same thing. So I think you can't really outsource any more functionality here, because saving a bow is just different from saving a player. It's not the same object, you have to treat them individually. Back in our main function, we don't need to manually create this directory now. We want a txt file saver instead, and it's a new txt file saver. and we'll store it at save files. And we have to create this into a string. And then we are good here. And of course, we could now do something like txt file saver dot save player and use the player here. And this is one way to do it for sure. But typically what you want is some syntax like this, player dot save to file. In order to achieve this, we'll remove this line. So of course, we now have to adapt the save to file function of our player. I'll rename it to save with, because what we're now doing is we're not providing a file name, but instead we're trying to hand over a saver here, which is the txt file saver. And all we're going to do is we'll call saver.savePlayer, and we'll hand over the self, and we're good. We're doing the very, very similar thing here with the bow. We'll have the save with again, and we have the txt file saver. Changed it here, and of course we'll have to hand over a reference to the txt file saver. And we're already good. Let's check if this runs. Of course, we forgot the question mark here to forward the error. And we've got some unused imports. We'll deal with them right now. And now, second try. Let's run this. Yes, this works. We'll have some new files. Just make sure, delete those, run again. Yes, the save files are coming up quite nicely. Everything's okay. So what we did here was a very, very simple implementation of the visitor pattern. In this case, our txt file saver is the visitor, because it comes to visit the player and the bow. The player and the bow then have to accept the visitor here in the save with function. And this allows both the player and the bow to call a method of their own without implementing how this method will work on their own. So let's take a bit of a closer look now. What advantages have we gained? Well, we now adhere to the single responsibility principle. All the logic to save items to a file is now in a single place, which is the persistence file. And of course, we could outsource some common functionality here, like opening files and writing to a file. Also, this kinda now halfway adheres to the open-close principle. If the way to save a txt file changes, the other structs, player and bow, don't need to change at all. Additionally to that, the txt file saver can now have its own state, which is kind of nice. And it is no longer the responsibility of outside code, here our main function, to know the file names, which is also quite nice. So let's take a look at some disadvantages we still have and we're going to fix in the course of this video. We still have to individually call save with for every struct, which will become quite annoying if we have a lot of game objects. Remember the halfway adherence to the open-close principle? Well, it also halfway doesn't adhere to the open-close principle, what we've done here. Because if we completely switch to a different way of persistence, for example a JSON file or a database, we have to change the player and bow structs because they currently specifically take a txt file saver. What you generally want in object-oriented code is that the methods of an object are only concerned with querying and modifying its own state. And other cross-cutting concerns can be handled by a visitor without introducing unnecessary complexity into the object itself. It's nice to see a Git commit in which only one file is changed and immediately know what's up. So let us now take this pattern and our code to the next level. We'll introduce a first trait, which is going to be the trait persister, which every persister, everything that needs to persist, needs to implement. We have the function savePlayer, and it's gonna take the self and a player reference. And of course, it will reduce our std.io result of an empty result. And we'll have the same thing for the bow. Instead, we'll take a bow here. And that's good so far. Then we'll need to change our text file saver here a bit. Of course, we're going to have those two methods in a separate impl block, which is impl the persister for text file saver. Put that in, remove the pubs because this is by default for traits, because it's a public trait. And we're good. You can now ask, well, what did this do for us? Well, it allows us to fully adhere to the open-close principle. Because now we don't need to specifically take a text file saver, we can just take any persister that wants to persist a player, and this will work. Same, of course, for our bow. So now, when we want to have a different kind of persister, we don't have to change the bow or the player at all. And in order to prove this point, I'm going to implement a very, very simplistic other persister, which is basically not really a persister, but to prove the point, it's going to be a console printer. Doesn't even have its own state. And we're going to impl the persister for our console printer. And savePlayer does nothing more than print a line persisting player ... and it returns an OK. And of course, for the bow, we're doing something very similar, persisting the bow, and we don't actually need the player or the bow, doesn't matter. However, we can now do things like this. We can create our second persister, which is a console printer. Oh yeah, we don't have a new function, we'll do it like this. And then we can do player.savewith our console printer, and we'll do the same thing for our bow. And we of course need to bubble up any errors that might come up. And you see, it works out of the box. No need to touch player or bow anymore for now. We can have any persister that we want. Really nice. Oh, by the way, and those std.io results, of course, you should refactor that into something way nicer. Probably you would want some custom errors that you can convert into and then bubble up, because for the console printer, it doesn't really make sense to return a std.io result. If you're interested in that, I have a video where I completely explain how custom errors work and how you should ideally convert them one into another. So we're not going to do it in this project here. Well, there's one thing left I'd really like to change or I'd really like to improve, which is we still have to individually call save with for every struct. So nothing changed here at all yet. So the way to get rid of this individual calls is, of course, another trait. This trait is going to be called the persistible trait. Persistible. And this persistible accepts the visitor via a save with function, takes a self and takes the saver, which is the persister. And of course, this returns a std.io result of nothing. And now both player and the bow will, of course, implement this persistible. Again, not much to change here. And we're good. So what can we do now? Of course, we can now have a vector in our main function, which are the persistibles. This is of a type vector to references of objects that all implement the persistible trait. And in here, we'll just store references to our player and to the bow, of course. And now we can finally do this. Get rid of all that. And do for persistable in persistables. Persistable.save with. And this is our txt file saver. And if we really wanted to do this, then we could, of course, do this for the console printer as well. And we're good. Finally, we have this all cleared up here a bit, and we're good to go. A word about unit testing. A visitor is every tester's wet dream. Because functionality and state have nicely been separated here, the functionality, i.e. the visitor, can be tested on a mock object rather than requiring a possibly complex setup of real objects. This makes your test more focused, easier to set up, and super maintainable. From here on, you can take this any amount of steps further by doing a what I would call generalization, but it's basically just a renaming from here on. Why would we stop at the point where we say, okay, we want to have a visitor that persists the player? Why not do anything with the player, like create overlay hints, or maybe return an icon or whatever? So we can say this trait should be renamed not to persistable, but to game object in general. And our persister trait should maybe not be a persister, it should be a game object visitor. Of course, makes sense. Then the game object does not save with a game object visitor, but it just accepts a visitor. And this is kind of what you would commonly see as the lingo or the way to name those methods accurately. Of course, you wouldn't save a player here, you would visit a player in general, and you would visit a bow, of course. And now, yeah, we just need to clean everything up a bit. But I hope you can see where this is going. From now on, these are our game objects. And our visitors can basically do anything. So now you opened up Pandora's box to do whatever you want with this player or with a game object in general. And you don't need to ever touch this function again, because all the functionality that you're gonna add, persisting, getting hints, getting icons, whatever, is not gonna be part of your player or your bow class or whatever. It's gonna be part of an individual class that you can create in a single file, in a single module, where you collect all the state and all the logic required for that. And there's no need to touch the player or any of the items anymore. Now, don't you think that's beautiful? Because I think that's really lovely. Seeing how beautiful and nice the syntax is here with the loop, we can now finally understand why we did not want to have something like this, where we explicitly use our txt file saver to visit the player and visit the bow. Because this means we have to know what kind of struct or what kind of class we're visiting. We know we're visiting a player, we're visiting a bow, and we have individual functions to do so. Whereas if we go the indirection via the accept method, we can offload this burden of knowing what type we're going to visit to the type itself. Because the player, of course, knows that it needs to use visit player because it's a player. And the bow knows how to use the visitor by calling .visit bow because it's a bow, which then allows us to have this beautiful loop in the main function where we don't even need to think about any actual implementation types. We just need to think about the interfaces. The visitor pattern is an excellent choice if you want to reduce coupling in your code and increase modularity, something that is always recommended. It also keeps your structs leaner, thus avoiding objects with thousands of lines of code, and improving code organization. The visitor pattern is particularly beneficial when you have an object structure and need to perform different operations on it. And object structure here refers to objects that are related in some way. In our example, that objects were related via traits. Number 2, when the operations you want to apply are likely to change or evolve over time. When you want to avoid modifying the classes of the object structure itself, and/or the operations on the objects are complex and involve significant logic or data manipulation. This would bloat the object structs themselves. So, summing up, the visitor pattern is ideal when you have a set of related operations that needs to be performed on an object structure, but where it's undesirable or impractical to add those operations directly to the object structure itself. I hope you can now also see the inner beauty of the visitor pattern. If so, like and subscribe. I'll see you next time at Green Tea Coding.